Welcome back to the channel. My name is Samuel Bartlett. We talk about networking and cybersecurity. Of course, any opinions expressed in this video are my own and do not necessarily reflect any past, present, or future employers. So I want to talk a little bit about the OSI and TCP IP models. Going through it when you're learning about networking can be a struggle, especially when you're expected to kind of understand these models without understanding the technologies that live inside of them. It's really difficult, at least it was for me, to wrap my head around these concepts. So here at the left, we have the TCP IP model, the OSI model. You'll see that 3 and 4, when we're talking about the OSI layers, I can actually number these 1, 2, 3, and 4. 3 and 4 on the OSI model are identical to 2 and 3 on the TCP IP model, but you'll see we have some differences there at the bottom and the top. Now, in the reality of things, TCP IP actually won the battle, and so technically we use the TCP IP model, but for some reason we still use the OSI model to refer to things. I think a lot of that has to do with this differentiation here at the bottom between a physical cable and the data link layer, and we'll go into detail about that. A few different things. One, for the sake of this discussion, we're going to stop here at layer 4. I understand that some networking technologies can go all the way up to layer 7, especially when we're talking about advanced firewalling, web application firewalls, etc. That's not the purpose of this video. I'm going to really focus on layers 1 through 4 in the OSI model here, and how to categorize things in your head as you're going through and learning new technologies. How do we determine what layer it's in and why? So the first thing I want to start out with is protocol data units. So this is what we call the data when it's in a particular OSI layer. So at the physical layer, we're really talking bits, right? So we're talking ones and zeros. That's all it is. It's going over a wire. We'll have a positive or negative voltage to differentiate what the bit is. Now, when we're talking layer 2, we will have frames. Now, frames are going to be from our layer 2 technologies, something like Ethernet, frame relay, which you probably shouldn't see these days. There's a few other technologies that are at layer 2. Generally, these days, we're going to see most things go over Ethernet, and even ISPs a lot of times are moving to technologies to go over Ethernet in order to make everything more standardized and easier to use. Layer 3, we have packets. So you may have heard the term, a packet sniffer, and you kind of think of packet as the network thing. Technically, it's actually a layer 3 data that's at layer 3, right? Layer 4 is where we have our segments. And so over here at layer 4, we're talking about stuff like sessions, TCP, UDP, right? Quick. I believe there's some quick is kind of between layers 4 and 5, but for the sake of this, we'll say it's layer 4 for simplicity. Packets, we'd be dealing with IP technology, so IPv4, IPv6. There are some competing layer 3 standards that do exist, but we pretty much don't talk about them today, so pretty much talk about IPv4 or 6 here. Another thing I want to mention is devices. So a bit going over cable, really it's going to be a cable, right? That's what we're dealing with. We're dealing with typically Cat6 fiber cables. Cat5 is around a lot today, Cat5 or Cat5e. Cat7 I think is brand new, and of course as times change. Back when we had token networks and stuff, we would use a lot of coax cable for networking. So there's been a lot of different types of cables used. You can even have a little box that will convert a Cat5, Cat6 signal to sending Ethernet over your electrical lines, right? So lots of different options there for our medium or media, which I like to use the word cable because it's pretty clear to people, whereas media may not be as clear. That is used in a lot of training material though. Frames, so device here we'd be talking about switches. Now we do have layer 3 switches, which would live at layer 3, obviously. That's kind of where they get their name from. But a traditional switch is going to live at layer 2. It's going to run the Ethernet protocol. We're going to use MAC addresses in order to make forwarding decisions in the Ethernet protocol. We have other technologies that live at this layer. I'll just say stuff like spanning tree, link aggregation, or ether channel. Plenty of other technologies that live here, but I'll just leave it at that. Packets. When we're talking about devices, we'll talk about routers, L3 switches, maybe some firewalls. Typically, firewalls will live anywhere from layer 2 and layer 3 all the way up to layer 7. So depending on the firewall, some less advanced firewalls maybe kind of just live at the 3 and 4 layers, whereas some more advanced firewalls can go all the way down to 2 and all the way up to 7 when we're doing advanced inspection. So at layer 4, really we're talking about stuff like load balancers, web application firewalls. You're really getting into more granularity and things that aren't typically seen in your average small business, or kind of the direction that most of my students are going to be studying is kind of that basic structure of a network. You're not going to deal with this kind of stuff. This is going to be more advanced and more verticalized, right? So if you're in an environment where there's going to be stuff like load balancers and web application firewalls, it's probably a relatively large environment, and you're going to have more dedicated personnel as opposed to kind of a generic network person, right? For the sake of this discussion, we're not going to talk about 5 through 7. We could talk about some more advanced stuff. Again, kind of the web application firewalls, some of the more advanced network firewalls, NDR and stuff like that. That's going to do kind of all the way up to layer 7 inspection. But for the sake of this, we're really going to focus on these layers to understand the OSI model. Now, with that, I want to go over what this actually looks like going across the wire. So at the end of the day, we're really just trying to take data and send it from one place to another. So we're going to have data here, the application data really, and we're going to have to go downwards in order to get that onto the wire. So when it's in bit form, it'll actually be on the wire. So we're going to add, and I'm going to talk about headers, but there could be footers as well, depending on what protocols you're using, and I don't need to get into that. So anyway, you'll have a layer 4 header, which will be, now it's a segment, right? Because we have a layer 4 header. We're dealing with sessions here, TCP or UDP, right? TCP is stateful, UDP is sessionless or stateless. And we'll have our layer 3. We usually call this the IP header, right? So now it's a packet, right? Because we have that IP header added to it. We'll have to decide between IPv4, IPv6, or another technology that's at layer 3. An important note here is the reason we have these models is to compartmentalize the duties of the network stack. So if we were to make an improvement on our layer 2 abilities, we could exchange Ethernet for a better protocol without having to change IP, without having to change TCP and UDP, etc., right, and vice versa. So then we'll go ahead and add the frame header, or our layer 2 header, which will have things like our source destination MAC address. Now, an important thing to note is when we're actually sending this, we would typically send from a desktop, to some sort of routing device, maybe a firewall, could be whatever. Whatever our layer 3 boundary is, could be a layer 3 switch. When we send that data, within that local network, the switch is only going to know, layer 2 switch, is only going to know about Ethernet. It's only going to know about MAC addresses. So it's going to use MAC addresses to forward. Now, those MAC addresses are only within this local network. As soon as we get to a layer 3 boundary, a physical router or firewall that's doing a layer 3 switch interface, we're going to need to strip off this frame header because we're sending the destination to the default gateway, right? This interface IP address. It's going to strip off the frame because it's destined for me, so it's my frame. So I strip off that frame header. I look at the IP header and I go, well, this is not actually for me. I'm just the gateway. I'm going to pass it on. So now I'm going to create a new frame header with my MAC address as a source. and the destination of whatever the next hop is. Or it could be, if it's just another segment on the routing device, we could just send it to the destination. And if we go through any other layer 3 devices, we're going to do the same process. We're going to remove the frame header, we're going to inspect the IP header, we're going to determine it is or isn't for us, and then pass it on. So, depending on what we're doing, if we're using something like a web application firewall or a load balancer, we may strip off the IP header. Typically, that's not the case. Typically, and if you're doing like a Cisco exam, for example, the IP header is going to stay from end to end, right? That's normal behavior. We may have some differences if we're doing NAT, if we're doing something advanced with like a web application firewall, where we're doing a proxy, or if we're doing another kind of proxy, right? So you could be doing web proxying, which is a lot rarer to see these days, but does still exist out there. We could be doing some other kind of proxying. So zero trust network access is coming up quite a bit as a VPN replacement. It's essentially a proxy, right? So we'll be changing and modifying that layer 3 header or that IP header. So hopefully that gives you kind of a little bit of perspective. I know that those of you who are studying to go get into network engineering, a lot of times these concepts are required before the actual technologies that get categorized. And so as you go through and you learn these new technologies, try to think through, okay, what device does this run on? Is this a switch? Is this an AP, a router? Does this run? This runs on a switch, right? Spanning tree. This runs on a router. It's HSRP. It's a routing protocol like BGP or OSPF, right? All these technologies, you can go, oh, they run on a router. Pick one of these concepts, whether it's a PDU, typically not PDUs, but typically devices or protocols, or like addressing, for example, right? Does this use Ethernet? Does this use IPv4, IPv6 addresses, Ethernet addresses, MAC addresses? So when you're thinking about, like your MAC table, for example, again, right, we're talking about MAC addresses. It's running on a switch, so that would be at layer 2, right? We're talking about a routing table, right? We're talking about IP addresses. We're talking about routers. It'd be a layer 3, right? So, as you're learning about technologies, as you're understanding technologies, thinking about, okay, well, what other technologies does this rely on? IP, MAC addresses, and Ethernet. Then we can kind of start to categorize, okay, where it lives in the OSI model overall. Again, right, we're just using this as a framework to categorize different technologies and compartmentalize our networks, so that if we do replace any of these, which we have, right, things like IPv6 came out, things like QUIC is coming out and becoming more and more prevalent, right? We have that granularity to where we can swap out without having to modify or change the rest of our infrastructure along with that. So I hope this has been helpful. I hope this has kind of opened up some additional ways of thinking about the OSI and TCP IP model to really wrap your head around what does it really mean and how you can categorize things in a particular model at what layer it is. So hopefully this helps, and I'll see you next time.